Hello students, welcome to Mathverse. This is Vishal Prakash. I know that you have finished the intermediate exams recently, and this is a time where you'll be focusing more on the JEE main second session, right? So today I thought I'll bring the top 10 PYQs you must learn before you go to your JEE main second session. And today I'll be taking the topic quadratic equations. So let's take the first question for today. This question was asked in JEE Advanced 2025. Let's look at the question first, right? Let capital R denotes the set of real numbers and let AI BI belongs to capital R where I is equals to set of 1, 2, 3. Now there are three functions given f, g, h whose domain and also codomain also are capital R and also capital R which are real numbers. Now three functions are given to us f of x, g of x, h of x. You can just look at the functions given there f of x, g of x, and you can notice that h of x is a function which is given in terms of f of x plus 1 and g of x plus 2 functions here, right? And the most important part here is the last statement. If f of x is not is equals to g of x for every x belongs to capital R. So this is a main part there. If f of x is not is equals to g of x for all x belongs to real numbers. Then we have to find out the coefficient to execute in h of x. Okay, now let's start analyzing the question here. The first thing, f of x and g of x are already given to you. The only thing is you have to construct the function h of x. So let us do that. So if you look at the function h of x here, h of x is given as f of x plus 1 minus of g of x plus 2. So let us try to write down f of x plus 1 function, right? Because already we have the function f of x there. So f of x plus 1 is nothing but a1 plus 10 times of x plus 1 plus a2 times of x plus 1 whole square plus a3 times of x plus 1 whole cube plus x plus 1 to the power of 4. And then minus of g of x plus 2 is also there. So minus of, let's write down function g of x plus 2 here. So what will be g of x plus 2? Nothing but b1 plus 3 times of x plus 2 plus b2 times of x plus 2 whole square plus b3 times of x plus 2 whole cube plus x plus 2 to the power of 4, right? So now we have constructed the function h of x. Now clearly we see a polynomial function here. Now here we need to calculate the coefficient of x cube in the entire function h of x. Okay. Now, so since we are trying to find out the coefficient of x cube, you can notice that all these terms will not give you any x cube terms because the highest degree there in the three terms itself is 2, so it's not possible. Similarly, if you look at this terms in the bracket here, these three terms also will not give you any x cube terms. So the only terms which will give you x cube is this one, four terms, right? So that is why what we'll do is we'll try to take coefficient of x cube from there. So let's try to observe this one. When you expand this x plus 1 whole cube, coefficient of x cube is going to be 1. Okay. And similarly, when you expand x plus 1 to the power of 4, the coefficient of x cube is going to be 4c3 because it is the expansion of x plus 1 to the power of n, right? Similarly, if you look at the second line here, x plus 2 whole power 3, when you expand, you get the coefficient of x cube as 1. And similarly, in the last term, x plus 2 whole to the power of 4, the coefficient of x power 3 is going to be 4c3 multiplied by 2 to the power of n, 2 to the power of 1, I'm sorry, right? So if you try to collect only the coefficients of x cube here, so let's write down that coefficient of x cube in h of x will be is equals to, first we have a3 into 1, so which is a3, and then plus 4c3, and then since we have minus sign here, so it will be minus of plus b3 times of 1, which will be b3, and plus 4c3 into 2 to the power of 1. Okay, now let's try to substitute these values of 4c3 here, and finally what we get is a3 plus 4c3 is 4, we know that, minus of b3 minus of 4c3 is again 4. 4 into 2 is, which is 8. So it will be minus of 8. Finally, what we get is a3 minus b3 minus of 4. So this is the coefficient of x cube in h of x. But the question is we have to find out the coefficient of x cube, but which means we are still supposed to calculate the value of what? A3 minus of b3. For that, we are going to concentrate on the last statement in the question. Look at that. F of x is not is equals to g of x for every x belongs to capital R. Okay, first of all, let's write down f of x not is equals to g of x equation. F of x not is equals to g of x, they are saying, right? So if you substitute this f of x and g of x functions, what we get is a1 plus 10 into x plus a2 into x square plus a3 into x cube plus x to the power of 4, which is not is equals to g of x. G of x is nothing but b1 plus 3x plus b2 into x square plus b3 into x cube plus x to the power of 4. Okay. Now, when I remove this x to the power of 4 terms and then bring all the terms to the one side, what I'm going to get here is a1 minus of b1 plus 10x minus 3x, which will be 7x, plus a2 minus b2 multiplied by x square plus a3 minus of b3 times of x cube is not is equals to 0 for all x belongs to capital R. So this is the main thing in the question. Let's try to concentrate more on this. They are saying that this equation is not is equals to 0 for all x belongs to capital R, real numbers. Okay. But the main thing we have to notice here is the left hand side is a cubic polynomial. Okay. So what is the thing that we know about a cubic polynomial or any odd degree polynomial? We know that any odd degree polynomial will be having at least one real root. That's a basic thing about any odd degree polynomial, right? Because if you take any odd degree polynomial like a linear function or also cubic polynomial, fifth degree polynomial. So every odd degree polynomial will have at least one real root. But here they are saying that this cubic polynomial can never be is equals to 0, which is impossible. So the only possibility is it should not be cubic polynomial. So if it is not a cubic polynomial, what happens? The coefficient of x cube is going to be 0, right? So what we do is we simply put a3 minus b3 is equals to 0 since it cannot be a cubic polynomial, and we know that cubic polynomial will have at least one real root. That is why we are trying to make the coefficient of x cube is equals to 0 so that it can never be a cubic polynomial. And hence we get the value, right? That from here a3 minus b3 is equal to 0. That is a3 is equals to b3. So coming back to this coefficient of x cube, our required value, so what's our coefficient of x cube that we have got? That is required is equals to a3 minus b3 minus of 4. Okay. And since a3 is equals to b3, so remaining will be minus 4. So which means the required coefficient of x cube in the function h of x will be. So let's take the question number 2. Now this question was asked in the January mains 2026, which was very recently done, right, in January. So let's look at the question. Let set capital S is given by set of x cube plus ax square plus bx plus c, where a comma b comma c belongs to natural numbers. And also ABC must be less than or equals to 20, be a set of polynomials. So what do we understand from this first statement of the question? That in the set S, we are trying to put all the polynomials which are satisfying the two conditions. And then let's read the remaining question. Then the number of polynomials in the set S which are divisible by x square plus 2. Okay, the way the question was framed here is very good. So first what I'll do is I will take the polynomial mentioned in the set S as some function f of x. F of x is equals to x cube plus ax square plus bx plus c. And they said that this polynomial f of x is divisible by the polynomial x square plus 2. So what is the meaning of that? That x square plus 2 is a factor of this polynomial f of x, right? So by using factor theorem, we can express this function f of x as the factor x square plus 2 multiplied by some other polynomial g of x. But very clearly, left hand side we have a cubic polynomial, that is f of x. Right hand side we have product of two polynomials and one of them is quadratic, which means the other one must be definitely a linear polynomial. That is the only way, right? So that is why what I'll do is I'll take g of x is equal to some mx plus n. But most importantly, left hand side, if you look at the function f of x, there the leading coefficient is 1, right? And what about the right hand side, x square plus 2 multiplied by mx plus n? If you expand completely, the leading coefficient is going to be m there. Since if you equate the similar coefficients, I can say that m is equal to 1 by equating the leading coefficients directly, and hence the equation reduces to f of x is equals to x square plus 2 multiplied by x plus n, because m is equals to 1. Now let's expand completely on both sides of the equation and we'll try to equate the corresponding coefficients. So ax square plus bx plus c, that should be equal to right hand side. If we expand, x square into x will be x cube plus, which will be nx square plus 2x and plus 2n. Okay. And let's equate the similar coefficients on both the sides, corresponding coefficients on both the sides. We can notice that the coefficients of x square are a and n. So a must be is equal to n. And if you equate the coefficients of x on both sides, you get b is equals to 2. And if you equate the constant terms, we get c is equals to 2. Okay. Now, one thing is very clear. The value of b is fixed here because b is equals to 2. There is no change in that. So it's fixed. The only thing that is varying here is a and also c. And most importantly, since you got the a is equal to n, I can substitute that in the second condition and I can conclude that C will be is equals to 2 times of A. So we have established the relation between the values of A and C here. Now let's go back to the question here. They said that ABC must be belonging to natural numbers. Moreover, they must be less than or equals to 20. So obviously you have to write down the cases here, right? Because if I take A is equals to 1, this will imply B is always is equals to 2. So let us not write every time. So if A is equals to 1, C will be is equals to 2. And if A is equals to 2, C will be is equals to 4. If I proceed in this way, up to A is equals to 10, I will get C is equals to 20. But clearly, A cannot exceed 10 here, right? Because if A is equals to 11, what happens? C will be is equals to 22. And we know that from the question, ABC should be less than or equals to 20, which means only 10 combinations of A and C are possible. Okay. So I'll mention that also. So only 10 combinations of A and C are possible. But let's keep in mind B is always fixed, which is equals to 2. Okay. Now look, let's read the question again. We have to find out how many polynomials in the set S are there. So clearly, the number of combinations of a comma b comma c will be giving you the total number of polynomials in the set S here, right? So if you try to take the total number of combinations of a comma b comma c here, b is always fixed, which is equals to 2, and a and c combinedly can be put in how many ways? Exactly 10 ways, right? Because we got exactly 10 cases for A and C. So in total, B can be filled only in one way, whereas A and C can be filled in 10 ways, which means totally there are 10 combinations of A, B, C, which are possible. And finally, the total number of polynomials, required polynomials will be is equals to what? Take the question number 3. This is also a question from the very recent JEE Mains January session 2026. Let's read the question. The smallest positive integral value of a for which all the roots of the biquadratic polynomial x power 4 minus ax square plus 9 is equals to 0 are real and also distinct is equals to. Okay. So this is an easy question, but there is a small mistake generally students do in this question. So let's try to see what it is. First of all, I will take the polynomial that is x power 4 minus of ax square plus 9 is equals to 0. So obviously you would have got the idea by now, right? That I can put x square is equals to t here. So if I put x square is equals to t, the polynomial here changes to what t square minus of a into t plus 9 is equals to 0. Okay. Now, this equation is a second degree polynomial that is in terms of t, and this will be giving you two roots. Let's assume t is equals to alpha, t is equals to beta. But what is actually t here? X square. So, which means x square is equals to alpha comma beta. Okay. But if you look at the question, actually, it's a biquadratic polynomial and which will have maximum four roots, right? But they are saying all the four roots must be real. Moreover, they must be distinct also here. So for that to happen, I need to make sure first that alpha beta are real numbers. So since alpha beta are real numbers, I can directly say for this quadratic polynomial in terms of t, delta should be strictly greater than zero, right? Because if x square is equals to alpha comma beta, if alpha comma beta are complex numbers, will you get the question which is required, that is real roots, not possible, right? That is why first let's ensure alpha comma beta both are real numbers. So delta greater than zero. So if you apply delta greater than zero, what do you get? B square minus of 4ac, which will give you a square minus of 36 greater than zero. And hence you get a minus 6 multiplied by a plus 6 greater than 0. And you can use the simple wavy curve concept here, right? That you get a belongs to minus infinity to minus 6 union 6 to infinity. 6 to infinity. So this is the value interval of a for which the roots of this equation are real. But this is a condition for the second degree polynomial in terms of t. And this is not the final set of values of it. This is a common mistake done by students because our required equation is in terms of x, whereas the condition we are writing down here is for what? The second degree polynomial in terms of t. And that is why we have to ensure two more conditions that here, since I have two cases, x square is equals to alpha and x square is equals to beta, x will be is equals to plus or minus root alpha, and also x is equals to plus or minus root beta. So here, if you have to get four different values of x here, that is four different real roots of this equation, I have to make sure that alpha comma beta are also positive, because if alpha comma beta, if at least one of them is negative, what is the problem? Square root of alpha or square root of beta will become complex, so which will not give you real roots in that subcase, right? That is why one more condition should be there, that is alpha comma beta both must be greater than zero. So alpha comma beta both must be positive here. Now we know when simple one simple logic, right? That if two numbers are positive, what happens? The sum of them is positive and product of them is also positive. So what I'll do is simply alpha plus beta greater than zero and also alpha into beta greater than zero. So what is this alpha plus beta for this quadratic polynomial here in terms of t? Sum of the roots will be is equals to a, a greater than 0. And also, what is product of the roots here? That is c by a, which is 9, which is greater than 0. But 9 greater than 0 is anyhow true, always true. And then the remaining condition that we're going to get here is a greater than 0. So, which means you must take the common part of these two. So, you should take the common part of these two. So, if you take the common part, what do you get? A belongs to 6 to infinity. So, this will be your final interval of A. Okay, na? So as I told, the small mistake students might commit here is they will stop doing the question when you do that A belongs to minus infinite to minus 6 union 6 to infinity, because even in the question also they are saying smallest positive integral value of a. So if you stop at this point also, you'll still get the correct answer for this question. But that's not the final set of values of a. You must also put the two other conditions, that alpha plus beta greater than 0 and also alpha into beta greater than 0. So alpha plus beta is sum of the roots, which is a in this case. So a greater than 0 and also alpha into beta 9 greater than 0, which is obviously true. So finally, we get the result a belongs to 6 to infinity, open 6 to infinity. And since they're asking about the smallest positive integral value, obviously it is a is equals to 7. I hope it is clear. Right? So let's take the question number 4 here. This is also a question from the recent JEE Mains 2026 January session. The question is very easy actually, but the thing is some students got very confused with this question, like how to proceed for such questions. So the question is simple as I told. I will give you the small trick also for this. So let's read the question first, right? A building construction work can be completed by two masons A and B together in 22.5 days. Person alone can complete the construction work in 24 days, less than person B alone. Then the person A alone will complete the construction work in. Okay, so first thing what I'll do is I'll assume let person A will take x minus 24 days to finish the work here because I'm going to assume that the person B will take X number of days. Okay, because they are saying that the person A can complete the construction work in 24 days less than the person B, right? It is by first, if I assume the person B is taking X days to finish the work, then obviously person A will take exactly X minus 24 days. Okay. The small thing here we need to remember is the concept of work rate. Concept of work rate. So work rate is nothing but the rate at which work is being done, which is simply 1 divided by time taken. Okay? Simply remember this logic. Work rate is nothing but 1 divided by time, or also in simple words, work rate is a rate at which work is being done, which is equals to 1 by time taken. Okay. So let's try to calculate work rate for person A and also person B. Okay. Work rate for person A and person B. So for person A, the work rate will be, let's take it as W1. Work rate is equals to 1 by T1. And T1 here is indicating time taken by the first person. So 1 by X minus of 24. Similarly, work rate W2 of the person B will be is equals to 1 by T2. And W2 will be is equals to 1 divided by X because person B is taking X days to finish the total work. Okay. Now, the main property we have to remember here is when two persons or two or more persons are doing the work together, we have the formula for that directly. That is combined work rate. Let's call it combined work rate and let's take it as capital W, which will be is equals to W1 plus W2. Okay, so this is a simple trick that you can remember here. So whenever two or more persons are doing the same job simultaneously, now the combined work rate should be is equals to the sum of individual work rates. Now, by using that concept here, I can find out the combined work rate, that is work rate is equals to uh, W1 is what? 1 divided by x minus of 24 plus W2 is 1 divided by x. Okay. But if you look at the question here, in the first statement, the construction work can be completed by A and B together is 22.5 here, right? Indirectly, they have given you the total amount of time taken by A and B when the job is done together. So, which means we can calculate the combined rate of work. That is, W will be is equals to 1 divided by 22.5 because together they can finish the job in 22.5 days, right? So as we know, work rate is always is equals to what? 1 divided by time taken. So directly combined work rate, the capital W is equals to 1 by 22.5. So let's try to take that and substitute it here. So from which we get 1 by 22.5 is equals to 1 divided by x minus 24 plus 1 divided by x. Now we can simplify the remaining equation, right? I hope you will be able to do it from here, right? Because you can simply take the LCM, that is 1 by 22.5 is equals to x plus x minus 24 whole divided by x times of x minus 24. So remaining you're going to get the quadratic polynomial. You can solve it directly. So let's cross multiply. What we get here, x square minus of 24x is equals to 2x minus 24 multiplied by 22.5. So let us try to simplify this equation here. So right hand side, what we get is 22.5 times of 2, which will be 45x, and minus of again 22.5 multiplied by 24 will give you 540. So finally, what we get is x square minus of 69x plus 540 is equals to 0. So I think clearly this can be factorized, right? Because 540 is nothing but 60 times of 9. So I can write this as x minus of 60 multiplied by x minus of 9 is equals to 0, which means either x will be is equals to 9 or 60. But if you look at this, person A is taking x minus 24 days. But if you try to put x is equal to 9, you get the number of days as a negative, which is not possible, right? So that is why the only possible value for x is equals to 60. And what's the required part? The time taken by the person A who finished the work alone. So clearly, x minus 24 days is the time taken by the person A, right? So since you know x value, you can calculate the required answer. Okay. As I told, question is not difficult here. The only thing is you should know the simple concept that work rate is always is equals to 1 by time taken. And when two or more persons are doing the work simultaneously, we can say that combined rate of work W is equals to sum of individual work rates. Okay. I hope the question is. Let's take the question number 5 now. Set C is equals to set of ordered pair x comma y such that x square minus 2 power y is equals to 2023, where x comma y belongs to natural numbers. This is one of the interesting question which was given in 2024 JEE mains. Okay, let's try to understand it. So I will write down the given equation in this way. X square is equals to 2 to the power of y plus 2023. Okay. And let's keep in mind that x comma y must belong to only natural numbers. Okay. And it's interesting because it's only one equation given to us, but how many variables are there in the question? Two variables. So if the number of variables is more than the number of equations, it's not easy to solve. The only thing is we can simply substitute and do the question, right? Substitution means it's like not the usual methods. We have to do some other methods. Okay, let's try to see what is the method here. First thing, what I'm going to do is I will write this 2023 in this way. Look at this. This is the idea. This is the best idea that this for this question to do. So I can write this 2023 as 2000 plus 23 plus 2 to the power of y. Moreover, I can write this 2000 as 8 into 250, and 23 I'll be writing it as 8 into 2, that is 16 plus 7 plus 2 to the power of y. Okay. I'll tell you what is the reason I'm writing in terms of 8 times of 250 plus 8 times of 2 plus 1. I'll tell you the reason. So here what I'm going to do is observe the term 2 to the power of y. Okay. The main advantage here is if y greater than or equals to 3. Okay? If y greater than or equals to 3, we know that y belongs to natural numbers. So two more cases are also obviously possible. That is y is equals to 1, comma 2. But let's start with y greater than or equals to 3 and come back to y is equal to 1 and 2 later. So if y is greater than or equals to 3 here, I can say that 2 power y is always a multiple of 8. So let's take it as is equals to some 8 times of 8, because if whenever y is greater than or equals to 3, 2 power y will be always a multiple of 8, obviously, right? So if I try to take that and put it here, I get the equation as x square is equals to 8 times of 250 plus 8 times of 2, and 2 power y here is nothing but 8k and plus 7. Okay, the main uh, advantage by doing so is all these numbers here, the three numbers, 8 into 250 plus 8 into 2 plus 8 into k is always what? Multiple of 8. Is always a multiple of 8. Okay, so which means here on the right hand side, it will be always what? Some 8 multiple plus 7. So if I try to divide the right hand side by 8, it will always give you what? Remainder as 7. So let me write down that. If RHS is divided by 8, remainder is always is equals to 7. Okay. But this entire right hand side is also is equals to left hand side, where we have left hand side is equals to x square. And let's keep in mind that x belongs to natural numbers here. Okay. So if right hand side is leaving remainder 7 when divided by 8, it's very obvious that when you divide the left hand side also by 8, it has to leave the remainder 7. Okay. But the main problem here with the left hand side is x square is a perfect square. X square is a perfect square. The main advantage with perfect squares is whenever you divide perfect squares with 8, okay, whenever we divide perfect squares of natural numbers by 8, the only possible reminders are 0, 1, 4. You can take any example and verify it. You can take any example, any perfect square, and try to divide by 8, and the remainder will be either 0, 1, or 4, which means the left hand side can never leave the remainder 7 when divided by 8, which makes this case not valid here. That is why, in this case, I can conclude that y greater than equals to 3 is not possible. Is not possible. I hope it is very clear to you. So once again, I will conclude this. If you take y greater than or equals to 3, the right hand side, if you observe that, it will be a multiple of 8 number plus 7, which means if you divide the right hand side by 8, it will always leave the remainder as 7. So if the RHS is leaving the remainder 7 when divided by 8, left hand side also must leave the remainder 7 when divided by 8. But what do we know about perfect square? As I just told, any perfect square when divided by 8 will only leave the remainders as 0, 1, or 4, nothing else. So which means left hand right, it's impossible case, right? That is why y greater than or equals to 3 is not possible. So the only cases which are left to verify is y is equals to 1. Okay, so let's try to check for y is equals to 1. If y is equals to 1, then what is the equation now? X square is equals to 2023 plus 2 to the power of 1. So which is x square is equals to 2025. And this is nothing but the perfect square, that is 45 square. So x is equals to 45 in this case. Okay. And let's check for y is equals to 2 also, if it is possible or not. If y is equals to 2, we get square is equals to 2023 plus 2 square, which is 4, and we get x square is equals to 2027, and here x cannot be is equals to natural number because square root of 2027 is not a natural number, which means y is equals to 2 is also not possible. So to conclude, since y belongs to natural numbers, we understood that y greater than or equals to 3 is impossible case, and y is equals to 2 is also not possible case, and the only possible case here is what? Y is equals to 1. And when y is equals to 1, what did we get? X is equals to 45. So that is the only possible ordered pair here is x comma y is equals to 45 comma 1. And if you look at the required part, that is sigma ordered pair x comma y belongs to capital C, x plus y. Since there is only one possible ordered pair of x comma y, that is 45 comma 1, I can substitute it. That is 45 plus 1, which is equals to 46. Okay. So if you had got one more extra ordered pair, you would have added that separately. Okay. So this is the reason I call this question as interesting. Without direct substitution, we are trying to use the simple concept of what? Remainder theorem. Okay.